Hello everyone, welcome to the session. So now in this particular session, we are starting our very new upcoming module. And I believe that before coming to this module, you already have covered up my previous module where we have talked about the introductory concepts of machine learning, right? Now, after understanding the concepts of supervised learning, unsupervised learning, semi supervised learning, I believe that it's the right time that we should start in a great detail regarding the supervised machine learning and what algorithms do we have in that particular problem, and at what point of time we should apply which kind of algorithm. That is something which is really, really important to understand. Now, in the complete modules of machine learning, you will observe one thing, that is the flow, the way I am teaching. And I believe that if you will follow that kind of approach, that will really help you in order to grab the further concepts of data science which we have in deep learning as well as in NLP. So how basically the flow will go for every algorithm that we will discuss in future as well. The very first thing which we have to pay attention is the mathematical intuition behind every algorithm. See, it's very, very easy to do the implementation, because nowadays in Python we have so many packages. We just need to install that and we can directly do any kind of implementation whatever we want, right? The important thing which differentiates you from any other person is that how depth knowledge you have in terms of foundations. So my target with respect to my audience is that they will be able to understand the mathematical intuition of each and every algorithm. So we are starting our very first supervised learning, and that is, as you can see on the board, is linear regression. So before moving ahead towards the linear regression concepts in a great detail, let's have a brief review about what is supervised machine learning algorithms, what is the meaning of supervised machine learning. I hope you are already aware about the fact, but let me just give you a brief overview of this. Supervised machine learning, I think we already have covered up in the last module. So, whenever we will be having a target data available with us, so whenever we're talking about a machine learning domain, we already have discussed that we will be dealing with a huge amount of data, right? Now, data can be of different forms. Simply, when we are dealing with the numeric based data, or you can say categorical based data, at that point of time, let's assume that you are solving any problem, and in that problem, a target value is given to you. For example, let's take a very simple example. Maybe you will be having a problem statement of diabetic prediction. So I am saying that you will be having the features of the patients. For example, how much is the BP value of that particular patient? For example, how much is the insulin level of that patient? So you will be having all those features which are responsible in order to diagnose that whether a person is having a diabetes or not. Insulin is there. Maybe the second feature is, let's say, how much is the age of that person, how much is the age of that person. So let's assume that you will be having multiple features, but at the end of every feature, for every row you will be having a target column. That is important to understand. So if we will be having a target column which indicates that for every record, either the value is 1 or the value is 0, or the value is 1 or the value is 1 or 0. So what is happening, for every record there is a mapping with either 1 or 0, and because this is available, that will be a part of a supervised machine learning algorithm. So always remember, whenever in any kind of a data set, whatever problem we are solving, if for every record a target value is available, that is always comes under the category of a supervised machine learning algorithms. Now, whenever we're talking about supervised machine learning algorithms, you will observe that we always deal with the two different kinds of problem statements. One example, which just now I have provided you, where I'm talking about that we need to do the diabetes prediction. So, whether a person will have a diabetes or not, right? There is a first example, which just now I have talked about diabetes prediction. Now, whenever we are talking about this kind of problem statement, either the answer will be 1 or the answer will be 0, right? There are two separate classes. One indicates that yes, a person is having a diabetes. 0 indicates no, a person is not having a diabetes. So, in a way, I can say that this is something which is a classification problem that we have, where we will be having multiple classes. We are not having any continuous number to predict. We have a separate classes, maybe 0, 1, 2, 3, and so on. It can be a binary class classification problem. When I'm saying binary class, I hope everyone understands that we will be having two classes. For example, the above example is a binary class classification problem where we have two classes, yes and no, right? Or second problem in the classification can be multi-class classification problem, where we will be having more than two classes. Okay? Multi-class classification problem, where we will be having more than two classes. Maybe it will be a ternary based classification problem where we will be having three classes, or we will be having four classes, and so on. So this is the first variety of supervised machine learning, problems that we will deal with. And the second variety of problems that you will deal with is regression, right? So what will happen in the regression based problem? You will observe that here we are trying to predict some continuous real value, real number. For example, let me say, again, you will be having the features. You will be having the features. When I'm saying features, these are the features, the columns that we have. This is F1 feature, F2 feature, F3 feature, and so on until Fn. And this is the value of y. In other words, I can talk in terms of F1, F2, F3 until Fn till the value, and the final last column is the y, which is the target value that we have. Now let's say I want to predict some problem like, house price prediction. House price prediction. Let's say I will provide you again the features or the columns of a given data set. I will say that, I will be having the feature like number of bedrooms available in a house, right? Maybe it's a 2 BHK or 3 BHK or 4 BHK, depending upon that. Obviously, the price will vary. Number of, I would say, washrooms that we have in a house, then number of balconies that we have, then maybe the locality that we have, and many more. So there are multiple features which are responsible again to get the prediction of the y. Now again, target value is available to you, the value of y is available to you, which is maybe, let's say for some house the price is 1 cr, for some another house it will be 50 lakh, right? 50 lakh. For maybe some another house it will be, let's say ki, 5 cr, and so on. So what is happening is that depending upon the feature values that we have, which is f1, f2, f3, until the value of fn. Again, if you will observe, I am talking about the columns only, which is available in my data set. The value of y is available. And because the value of y is available, again, you will call it as a supervised based machine learning, problem. Now, in this case, if you will be able to observe, we don't have as such classes. For example, in the previous example, which just now I have talked about, in the case of a diabetes prediction, we have a separate classes like 0, 1, 0, 1, and so on. But in this case, our answers are not a classes. Our answers are the continuous numbers, continuous real values are there. If you will observe, right? It is a continuous real number or real value that we have. I hope you will be able to understand. Here I can't classify it in some values. So that's why that kind of problem is something which we call as a regression based problem, where our prediction is a some continuous real number, some continuous real number. So at that point of time, we will call that kind of a problem as a regression based problem. Now, depending upon what kind of problem you are solving, uh, maybe classification or a regression, in that case, in machine learning, we have different set of algorithms. For example, the very first topic that we have in today's module that we will cover up in multiple videos is linear regression, which is the, I would say, very first foundation of foundational algorithm in machine learning, linear regression. Basically, this will be able to solve only the regression based task, meaning whenever at any point of time you want to predict any continuous real value, any continuous real number. For example, just now I have given the example of a house price prediction. Similar problem statements if you have, at that point of time, definitely you need to go for something called as a linear regression based algorithm. It's not that like that we have only single algorithm, We have multiple algorithms in machine learning, which basically helps us to solve a regression based task. And that is our task to understand in the upcoming modules, that what is the main thing which we have to focus on, how we get to know that, okay, with respect to this particular data set, linear regression works the best, or maybe some other algorithm also may works the best. So all the scenarios we will try to understand in this particular complete module of machine learning. Specifically, you will be able to observe that here we are focusing completely on this very first module, sorry, very second module, in case of supervised machine learning algorithms only, where the kind of data which we are dealing with, obviously for every algorithm I will do the hands-on live implementation of each and every algorithm that we are talking about. So at that point of time, you will observe that either we are trying to solve a classification based task, or we are trying to solve a regression based task. But now, as of now, we will focus on something called as linear regression algorithm. So I hope that now you will be able to get an idea that, first of all, what is supervised machine learning algorithm? Then two problems we have in supervised. One is classification, another one is regression. What is the difference between these two? Major difference we have talked about. And in the regression part, what is linear regression? Basically helps us to solve the regression based scenarios, where we will be having a task of predicting the continuous real values. Now, what we will do is, in the upcoming session, we will try to talk about that what's the mathematical intuition behind this linear regression, how basically with the help of this kind of algorithm, we will be able to get the prediction of any continuous real value. So basically, the important thing which you have to understand is, in the upcoming session, that how basically the mathematical intuition of linear regression works. Of linear regression works. That is the next upcoming task that we have to understand. But I hope that this intro part is pretty much clear to everyone. And now you guys have the motivation to move ahead and watch the video for the upcoming concept for the mathematical intuition behind the linear regression algorithm. With this, let's end today's video. I will see you all very soon in the upcoming video, where now we will talk about the intuition with respect to mathematical per se in case of a linear regression. And after that, in the upcoming videos, you will observe that once we will be able to understand the complete concept of mathematical intuition part, then we will try to do the hands-on practice, so that whatever things we have discussed so far, we will be able to do the implementation for the same. Bye-bye everyone, and see ya.